Right, my dear children, today I am going to explain you a problem related with the theory. I was done with you from my last video. Do you remember that theory? Right? I explained you, I told you about the reaction between sodium carbonate Na2CO3 with HCl. Sodium carbonate with HCl takes place in two steps. I was explaining you practically also. Do you remember it? Sodium carbonate with HCl, we know the products. Sodium chloride NaCl, carbonate with an acid should be given carbon dioxide, CO2 plus water. Then to be balance the equation, we must take 2 moles of HCl. Then the reaction occurs 1:2 ratio. This is the complete reaction of sodium carbonate with HCl, right? But I told you that I proved that experimentally. Do you remember doing 2 titrations also using the phenolphthalein and methyl orange? This reaction takes place in 2 steps. What are these 2 steps? First step, Na2CO3 reacts with HCl 1:1 ratio, giving sodium chloride and sodium bicarbonate. This is the first step. It occurs 1:1 ratio. So, if we want, we can stop the reaction at that state. Right? Then, the second step, the so-formed sodium bicarbonate again reacts with HCl to give sodium chloride plus carbon dioxide plus water. This is also 1:1 ratio. Then, see here, first step, sodium bicarbonate is formed. If we add more HCl, then second step, the so-formed sodium bicarbonate react with more HCl, giving carbon dioxide. Right? Then, if we add these 2 reactions, bicarbonate cancelling out because it is an intermediate compound, sodium carbonate, HCl 2 moles, form sodium chloride 2 moles here, and carbon dioxide and water. So, we must know that it occurs in 2 steps, the full reaction. So, if we want to find out the stop at that state after the completion of first state, we can use phenolphthalein as the indicator. If the phenolphthalein gives orange color to pink color to colorless, this reaction gets completed. If we use methyl orange, we will stop when the color change occurs from pink to red. So both reactions should both occurred. That means the reaction, full reaction should be occurred. It is happened due to the effect of the indicator, not the indicator. So indicators can be used to identify the two reactions, right? Some problems are given for your exam, right? Under the stoichiometry using this theory. Today I am going to explain you a problem related with this theory. Right? Now you must remind the previous knowledge. So the problem is given. There's a mixture of fertilizer. It contains CONH2 twice. CONH2 twice and ammonium sulfate. NH4 twice, SO4. What's that? Urea. Need the formula of urea. This is ammonium sulfate. The mixture is a fertilizer. Both supplies nitrogen to the soil. Normally, we are taking these compounds as the fertilizers, right? Then they ask to give how they react, how this mixture reacts with NaOH. NaOH. Then first of all, we must give the relevant equations for the reactions, how urea reacts with NaOH, how ammonium sulfate reacts with NaOH. I write here NaOH plus urea CONH2 to give, I write here, to give sodium carbonate Na2CO3 plus ammonia. I name this reaction as 1. So it is clear that ammonia should be 2 moles. Not CONH2 twice here. Sodium hydroxide should be 2 moles here. 2 moles. Here should be 2 moles. 2 NaOH. This is the reaction. NaOH plus urea to give sodium carbonate plus ammonia. This is the balanced chemical equation. So you have to write this equation as the first answer. Right? Then ammonium sulfate. How it reacts with sodium hydroxide? NaOH plus ammonium sulfate. NH4 twice, SO4. Ammonium salts give ammonia with a base. So here also sodium sulfate, 2NaOH here, sodium sulfate plus ammonia, NH4 twice gives 2 ammonia. Here water also formed with water. This is the second equation. I name this as second equation. These are the reactions relevant reactions for the fertilizer mixture with sodium hydroxide. Urea gives with NaOH ammonia with sodium carbonate. Urea gives only sodium carbonate, not even water also. NaOH gives ammonium sulfate, sodium sulfate, ammonia and water. Right? These are the two balance equations. Then, regarding these two reactions, the problem is given a fertilizer sample, liquid sample was taken 50 cubic centimeter. Aqueous solution of urea and ammonium sulfate. Both are contained in this solution, 50 cubic centimeter. So, add sodium hydroxide to this solution. How much? 1 m 35 cubic centimeter. 35 cubic centimeter. 1 m 35 cubic centimeter NaOH was added to that 50 cubic centimeter. Right? Then it is clear that NaOH, this solution contains urea and ammonium sulfate. After the addition of NaOH, these are the reactions should be occurred. These are the reactions should be occurred. Right? After the reactions occurred, so what are the products? What are the products in the solution? According to the equations, sodium carbonate was formed, ammonia evolved, it is a gas, then sodium sulfate, Na2SO4, these are the products, 1, 2, ammonia evolved. Then as a result of the reactions, two reactions, sodium carbonate, ammonium sulfate should be formed. They are present as in the ionic form. Ammonia evolved. Then it is given as normally the NaOH should be was added excess to be completed the reactions. Right? If it is excess, no urea or ammonium sulfate in the final mixture. If it is excess, definitely that solution contains NaOH also. Remained after the reaction. Added amount is known, remained amount of NaOH should be present here. Right? So these are the products. Then, according to the problem, two samples are taken, like similar, like this. Two samples. Right? Two samples like this. The one sample, the other sample. Two samples of the same mixture, A and B. These two samples are identical. That contains 50 cubic centimeter of the original fertilizer solution in both 50-50. NaOH, 1m35 NaOH was added to each 1m35 cubic centimeter at 1m35 cubic centimeter of NaOH. To this one also add 1m35 cubic centimeter of NaOH. So these two are identical solutions, A and B. If it's so, finally we can obtain two solutions, two identical solutions similar to this one. These are the two solutions formed from A and B. A and B are similar to this solution. Both added NaOH. These reactions are occurred in both. Finally, these are the results. Such two solutions are having A and B, identical solutions. Right? Is it clear? Then, these two solutions are titrated with HCl, titrated with 1mHCl. 1mHCl. Using phenolphthalein here as the indicator, methyl orange here as the indicator. So it is clear that two identical titrations, 1mHCl in the burettes, these two solutions are same, similar to this one, A and B, but for A, the indicator phenolphthalein, for the B, indicator methyl orange. Then, what is the color change is given here? This solution should be shown with phenolphthalein pink because NaOH is present. This one gives orange initially. At the end point, this becomes colorless. Then burette reading was determined. When the color change occurs from pink to colorless, the burette reading is 30 cubic centimeter. When the color change occurs here from orange to red, the burette reading is 50 cubic centimeter. These are the data of the problem. Right? This is the given problem for your exam. Then how we enter to solve this problem? We must know what are the reactions should be occurred. What are the total reactions should be occurred when HCl is added to this mixture. What are the reactions to be occurred, should be occurred? Right? Shall we go through these reactions? First one, sodium carbonate should be reacted with the added HCl. Then we know that sodium carbonate reacts in two steps. This is the time we have to consider our knowledge. Then I write here Na2CO3 plus HCl NaCl plus NaHCO3. It is named as third reaction. 1, 2, 3. Then the so formed sodium bicarbonate should be reacted with again HCl to give sodium chloride, carbon dioxide and water. This is the fourth reaction. This is 1:1. This is also 1:1. 1:1, 1:1. All the moles are formed same. So 1:1:1:1. The similar number of moles here also 1:1. Again 1:1:1. The two reactions should be occurred to be completed the reaction of sodium carbonate with HCl. So here I am writing the reaction should be occurred. Now sodium carbonate gets completed. It is completed. Then sodium sulfate with HCl. Carbonate reacts, but sodium sulfate, you must know that, does not react with HCl. Then you have a problem. Sodium carbonate, sodium sulfate, both are salts. Why sodium carbonate reacts with HCl, but sodium sulfate does not react with HCl? These points you must know very clearly. Right? The reason I'll give you, I'll explain in my lesson in future in detail. Now I tell you what is the reason. HCl is a strong acid. Sodium carbonate formed from the carbonate radical came from bicarbonate. It is a weak acid. Therefore, that salt is basic because sodium came from strong base sodium hydroxide. The salt shows the basic nature. Therefore, it reacts with acid, strong acid. See here, sodium came from sodium hydroxide, strong base. Sulfate came from sulfuric, strong base. So it is neutral salt. If the salt is neutral, it does not react with HCl. These points you must know very clearly. Right? Then no reaction of sodium sulfate with HCl during the titrations. Right? Then NaOH, it should be reacted. It is a base. Then second, third, NaOH remained react with HCl to give sodium chloride and water. It is the fifth reaction. See here. These are the three reactions should be occurred during the identical two titrations. Sodium carbonate reacts with two steps. No reaction with sodium sulfate. Sodium hydroxide remaining NaOH reacts with HCl. These three reactions should be occurred during the two titrations. Is it clear? Right? Then, if the same reactions, identical solutions are used, the same reaction should be occurred in both, but here the burette reading becomes 30 cubic centimeter. The used HCl 30 cubic centimeter volume in this titration. Here also 50 cubic centimeter was used HCl. So it is clear that more reactions should be occurred in this titration. Then we have to identify out of these three reactions, these are the reactions should be occurred. Out of them, what are the reactions are occurred in this titration and other titrations? Then it is clear that first one should be occurred in both. First one should be occurred in both. Because in the presence of phenolphthalein, we know that the sodium carbonate first step should be occurred. When we stop due to the color change, this was happened. When NaOH strong base, we are adding strong acid, it also should be occurred. When sodium carbonate reacts with HCl, in parallel to that, NaOH also reacted with HCl. So it is clear that these two reactions only occur in the first titration. But in this titration, the indicator is methyl orange. When color changes occurred, we know that both reactions should be completed. Then it is clear that in the second titration, third reaction should be occurred. Fourth also, the second step also should be occurred. This is common for all the states because acid-base reaction. Then, do you understand that, my dear children, this titration only occurs third reaction and fifth reaction only. But this titration, all the three reactions should be occurred. This should be, that theory should be clearly understood to solve this problem. Otherwise you can't do it. Right? Then, if we think we are using same HCl solution, no? 1:1, 1:1. All the moles are same. Here also 1:1, 1:1. All the moles are same. That amount of mole react with here also. Therefore, 1 and 2, all the number of moles should be same. Right? If it's so, 1 HCl, if x cubic centimeter volume should be used, was used for the first reaction, second reaction also used HCl volume should be x, because according to stoichiometric ratios, first one and second one both are having same number of moles. Then the volumes also same because the same HCl solution was used. But this is another new example. It is not same for these two. So that amount of HCl is given for y cubic centimeter. Right? If we assume the volumes of HCl for the first one x cubic centimeter, second one x cubic centimeter, both are same, third one y cubic centimeter. In the first titration occurred 3 and 5. Then what is the used HCl? total HCl volume, x plus y, x plus y here, x plus y cubic centimeter. Not here. For this one, x plus y, first iteration. Second iteration, all are happened, all are occurred. Then it is clear that x plus x 2x plus y, 2x plus y. These are the respective volumes of HCl. Right? I think you understood up to that point. Then it is clear that we have a relation. We have a relations. Now, the volume total volume at HCl was given here 50. Then we can give an equation 2x plus y should be equal to 50. This is the equation A. Here x plus y only, x plus y. Then x plus y equals 30. This is the equation B. I think you understood how we obtain these two reactions, two equations. Right? Then after that it is clear that using these two equations we can find out the value of x. X should be equal to 20 cubic centimeter. Right? Subtract B from A, by cancelling x becomes 50 minus 30 means 20. Now we are determined what is the volume of HCl here? 20. Here also 20. For the final reaction, after third reaction, 10. It is 10. So we can calculate the number of moles of sodium carbonate using this equation, number of moles of sodium hydroxide reacted with HCl using this reaction. Right? So, up to that, is it clear? Then, I'll go for the calculations. Taking third equation, number of moles of HCl, NHCl equals concentration into volume. Concentration is 1, volume 20 divided by 1000 moles per cubic decimeter. So it becomes 0.02. Similarly, 0.02. According to this reaction, the ratio is 1:1. Therefore, number of moles of sodium carbonate also equal to the number of mole of HCl, Na2CO3. Right? So, sodium carbonate, from where sodium carbonate? We have to find out the sodium carbonate. Right? The sodium carbonate was formed initially during the addition of HCl to the mixture of fertilizer according to the first reaction. See here. This is the formed sodium carbonate was formed initially. That amount of sodium carbonate was reacted with HCl during the titration. That amount should be 0.02. Then it is clear that amount of sodium carbonate is 0.02. According to the stoichiometry of this reaction, 2:1, 1:2. Ammonia should be given 0.04. Right? Sodium carbonate also 0.04. For the first reaction means to be reacted with urea, sodium carbonate 0.04 moles was reacted. Then NaOH, it is not this amount, no. That sodium hydroxide was remaining sodium hydroxide. After the addition of NaOH here, they react with your fertilizer sample according to these two reactions. Added excess NaOH, the amount of NaOH was remained. Then we can find out the number of moles of HCl here. 1 into 10 divided by 1000, it is 0.01. Therefore, NaOH moles also 0.01. The amount of NaOH was remained after these two reactions. Then we know that added amount of total NaOH was added 1 m 35 cubic centimeter, not 1 m really, 2 m 35 cubic centimeter was added NaOH initially for this reaction to occur these all the reactions. Then we can find out added amount of NaOH in NaOH total. How much? 2 into 35 divided by 1000. Number of moles 0.07. 0.07. This is the total amount of NaOH was added. This is the remaining amount of NaOH. Therefore, reacted amount NaOH reacted amount should be equal to added amount minus remained amount 0.06. Right? Then it is clear that NaOH 0.06 moles for 1 and 2 reactions. Here. For 1 and 2 reactions. Then NaOH 0.0 here, consider the first reaction. We had find out the sodium carbonate mole 0.02. Do you remember? According to the stoichiometry of this solution, NaOH mole should be 0.04. For the both reactions, 0.06 was used. For the first reaction only 0,4 was used out of the 0,6. Then it is clear that the remaining 0,2, total 0,6, for the first reaction 0,4 used, remaining amount 0T, the 0,2 should be that amount, 0,2. If it's so, ammonium 0,2, ammonium sulfate, according to the stoichiometry of this reaction, 2:1. If NaOH mole 0,2, sodium sulfate should be 0.01, 0.01 mole. Now it is clear. We had solved the problem. Urea moles, urea 0.02 moles were present in this mixture. Ammonium sulfate, NH4 twice, SO4, 0.01 moles were present in this mixture. These are the initial amounts of urea and ammonium sulfate were present in the mixture. Right? The total mixture, 50 cubic centimeter. Do you remember? I had erased here. 50 cubic centimeter volume was taken for the reactions, 50 cubic centimeter. Then it is clear that the total volume 50 contains urea 0,2, ammonium sulfate 0,1. If you know the number of moles of urea and volume, you can calculate the initial concentration of urea. Similarly, number of moles of ammonium sulfate 0,1, total volume is 50, then you can calculate the concentration of ammonium sulfate also. Right? This part you can do it very easily. Now you must know that, you must understand that how we solve this problem regarding these equations. It is clear that you must identify, you must know that what are the reactions totally should be occurred during any reaction. Then I want to show you that the sodium carbonate HCl reaction is very important for your exam. Right? Then I think you had understood clearly this problem, how to start, how to go through the problem and the calculations. So it is clear that not need to write any word in words. Everything can be given as writing the equations, giving the numbers. According to the numbers of the reactions, you can give the number of moles regarding N, and so not need to write sentences during the calculations. It is very important. You can save the time. Right? So I think you understood this problem. Thank you so much for my dear children. I will meet you again another videos recently. Then you can find out from the YouTube about my classes and their places. Then what is the type of classes and my numbers also. Then you can connect with me according to your likeness. Right? Thanks very much for you, my dear children. We will meet another day recently.